Hello, everyone. Welcome to today's session of Process Safety with Louise. I hope you're all keeping well and getting ready for Christmas. Today, as we said on the LinkedIn post, we're going to be looking at Bhopal, and we're going to be comparing that incident to two recent incidents and asking ourselves the question, have we really learned? Is there anything new here? The reason why I chose this subject was because I recently attended the Hazards Conference. And part of that was a presentation by Jasper and from Marsh, and he said that of the 100 greatest losses, only 5 of them taught us something we didn't know. The rest just taught us the things we knew again. So I wanted to look back at this incident and see if there, what commonalities we can have with recent day incidents and what can we learn, some of the things that we are learning again and again. So I'm going to share the screen, and I'll just ask you if you can confirm that you can see it. I don't need to share sound. Can you see a screen? If anyone can just let me know in the chat. Yep. Yep, great. Okay, and I'm going to share the screen now. I'll go back to the beginning. So this is our session for December. And before we get into the details, please remember that this session is being live streamed to YouTube and will be available for playback on the YouTube channel. So just be mindful of what you say. So don't say anything sensitive for your company or for yourself, and be respectful for others. Everybody who's on the call who may also answer the questions that you type in are all here voluntarily, as am I. So just be respectful of people volunteering their time here. What is Process Safety, Louise? So if you haven't attended before, it's a place to get access to industry experts. So myself and some of the attendees are industry experts in process safety. And every time I do one of these sessions, I learn something new from somebody who's attending. So please feel free to add comments in if there's something that that you have expertise on and you want to answer. It's varied, but typically I try to do it once a month, and it's a free session. It's available for catch up on YouTube, and it's a place to share best practices and for all of us to learn. Our aim here is to try and educate people for free so that eventually one day we might say process safety incidents were a thing of the past. So starting today, what is it going to look like? We do a quick introduction and a safety moment. This can take anywhere from, say, 20 minutes to half an hour. And then after that, I open the floor up for discussion, typically half an hour's worth of questions. And then we wrap up just 10 minutes before the end. Okay, you feel free to type your questions into the chat before or while I'm busy doing the presentation, so that when we finish the presentation, we can immediately get to answering questions. Okay, and you can also put the questions in anonymously if you're concerned about anything, but you just want some advice anonymously. Okay, so an introduction to myself. My name is Louise Whiting. If you haven't attended these sessions before, I've got over 11 years experience in operating assets, both in the project space as well as in the operating space, and also in the well space, predominantly upstream. Since 2019, I started my own business. And since then, I've been working HAZOP, LOPA, hazard, as well as process safety management audits and process safety general advice. And I've got a number of qualifications if you need any advice on how I got those, what best practice or what experience I did to get them, etc. Just give me a message on LinkedIn. So we first have a look back at Bhopal. It was December 1984, so 38 years ago. What happened? At Bhopal, they were storing a large quantity of MIC. MIC is a toxic intermediate which is used in the manufacture of fertilizer. And if it gets in contact with water, it begins a reaction. If the temperature of the reaction gets above a certain temperature, it then becomes a runaway reaction, evolving a large amount of gas. Unfortunately, this is what happened on the night in December. It was a very still night, and they went to the scrubber, but unfortunately the scrubber was not working. And then we had a water curtain which was not high enough, and then we should have been connected, the gas should have been connected to a tower, but again, that had been removed for maintenance. So the refrigeration system also, which should have kept this cool, was out of commission because they were trying to save money, and some of the refrigerant had been shipped to another plant. So this comes from the ICME bulletin. You've got the loss prevention bulletin there, 240. But this is another ICME bulletin which I really liked. So this is the one issued in 2019. And what we're looking at here is the slip bind was not installed. If the slip bind had been installed, it could have prevented water from entering into the MIC tank. The pressure gauge readings indicating that there was water going into the tank were ignored. Temperature measurements were not available within the tank, and the pressure of the tank depressurized by a leaky valve. There was a reaction, but the cooling system was switched off. If the cooling system had been on, then we wouldn't have had the runaway reaction. We then had the thermal runaway, which generated a large amount of gas. It should have gone to the vent gas scrubber, but that was in maintenance. If that failed, it should have gone to the flare, but that was in maintenance. And if all of that failed to protect the community from exposure to toxic gas, the water curtain should have operated. So in this line, we can see several failures. We can see failures in procedure. We can see engineering failures associated with the design and how it has been set up. We can see operational failures and maintenance failures. And these are all failures to maintain and operate key process safety barriers. Now, I know that from working in an operating site that things don't always go according to plan. You don't always have the right resources to do all of the maintenance on your list. However, you should be able to prioritize using, for example, the LOPA or the HAZOP. You should be able to prioritize those barriers which are associated with events which could have significant consequences. And as a result, in this case, these barriers that we see on the drawing, these are the ones which should have been prioritized. People should have been trained in the procedures. There should have been independent verification of steps. The measurements which were critical should have been high criticality on the control system, but also should have been placed in such a way that it can be seen and can be observed. The cooling system, which was high criticality, should definitely not have been decommissioned without a proper management of change, or but without removing the hazard, i.e. removing the storage of MIC on the facility. And then the other safeguards, which are the mitigative ones, which are equally important, they should not have been out of commission. And if we had used the bow tie, we would have seen that we wouldn't have had many barriers to prevent the toxic release to the personnel located nearby. One of the recent incidents we're going to have a look at is algae polymer. The very sad thing is that this happened just after the pandemic hit when we came back from the first lockdown, but it also happened in India. So not very long after Bhopal, in the country where we should have learned the most from Bhopal, we had very similarly a runaway reaction in a tank with releasing toxic gases impacting the local community. What was the problem here? How could we have prevented it? We needed to cool the storage tank, and we needed the storage tank to be cooled all the time. Unfortunately, the way in which the cooling was engineered and installed on that tank, it meant that there wasn't equal distribution of the cooling in the tank. And so the bottom of the tank was kept cool, but the top of the tank had the potential to have hot spots, and there was stratification in the tank. This was because of engineering failures, both in a management of change applied to the tank, but also in the original design of the tank. The tank was never designed to hold styrene monomer. The tank was designed to hold malt. It didn't have temperature indication at the right places, so you could see the temperature at the different levels in the tank. It was only measuring in one place. And the cooling arrangement was changed just before the pandemic lockdown. So in January, the cooling arrangement was changed because the inlet to the pump was changed from the top, as in a floating suction inlet, to the bottom, which was actually adjacent to the point in where the cold liquid came in. And as a result, there was sort of a bypass of the top of the tank through this cold circulation. Why did this happen? Because they were seeing a lot of styrene particles in the suction of the pump, which meant that the pump wasn't operating very reliably. So they decided to change the point of the suction. However, they unfortunately lost the importance of having the suction at the top, which meant that cold fluids, so warm fluids were taken into the cooling system and cold fluids were returned, right? So to get that circulation in the tank, they unfortunately lost that importance. The inhibitor concentration was not high enough to inhibit, and they didn't have sufficient inhibitor because of the COVID lockdown. Now, other sites who handled this dangerous intermediate had sufficient inhibitor. So why did they not have it here? It's again one of those critical barriers which wasn't seen as sufficiently important or sufficiently high to be able to maintain it. So again, one of those things that we saw from Bhopal, it's one of our layers of protection which had been eroded over time. We have proper engineering of the change. So the first one was change of the use of the tank, and the second one was change of the flow distribution, which we've spoken about. And then also quick emergency response. So they did have detection which could detect the styrene, and they did have some alarms, but they didn't then evacuate personnel in close proximity to the facility, which again is something that is similar to what happened in Bhopal. People were asleep, it was nighttime, and they were not evacuated to protect them either. Now, in both of these, perhaps they didn't have a written procedure. I don't know the exact details of why this response was not done, but they didn't do this, and as a result, people were exposed to toxic gases. Fortunately, in the algae polymer, the number of fatalities was not as high as Bhopal, but the similarities between the two incidents is very tragic to think that this could happen in the same country in a very similar way. Now we'll move over to an event that happened in the US in the Evergreen packaging paper mill. So this is a bit of a different incident. A video was recently released by the CSB, but they had two work parties. One work party working in this part of the tower and another work party working in this part of the tower. In the downflow part of the tower, they needed to apply a resin. The resin had some problems setting at low temperatures, and they were doing this work at night because it was part of a turnaround, and they were trying to execute it quickly. So they decided to try and heat the resin, and they used a heat gun. Unfortunately, the resin was flammable, and as a result, when they were using the heat gun accidentally fell into the bucket and set fire to the bucket. The team working in the upflow tower had an escape route. You can see just behind this area of singed pipe here, and that was their only escape route. When that set fire, the smoke started to come out of the escape route, and unfortunately, the people in this part of the tower were overcome with smoke and were not able to escape. So how could this be similar to Bhopal? Well, what went wrong was hazard identification or understanding the hazards associated. Now, sometimes we do understand the hazards initially when we first design. So for example, at Bhopal, they did understand that MIC had a significant potential for fatality, which is why they had all those layers of protection. But over time, the understanding of the hazard was eroded and people lost the importance of the barrier. Here, unfortunately, in this incident, they didn't identify the hazard, the potential for ignition. And as a result, they couldn't put the barriers in place. Although, actually, if we look back, the company who were doing the work in the downflow tower knew that the resin was flammable and also that it didn't set at low temperatures. And so they had a different way of heating up the resin, which was heating bands, which are suitable for the zoned area, and you're not requiring ignition sources inside the confined space. Okay. Job planning. So planning what would happen when it went wrong. So in Bhopal and algae polymer, there wasn't appropriate emergency response. And we don't know exactly the reason why there wasn't appropriate emergency response. But in this one, it's almost as if emergency response wasn't thought of proactively. Because if emergency response had been thought of before starting the job, the question is, would we have allowed the two work parties to work together, knowing that the resin was flammable? It's unlikely that we would have allowed the two work parties to work in the same confined space, knowing that neither of them could see what the other one was doing, they had different escape routes, and that the resin was flammable. And then we talk again about segregation of hazards or minimizing the hazard. So here, in this incident, yes, the resin set fire, which was in the barrel. But unfortunately, because the resin was used and it was applied to the tower, once that set fire, the rest of the tower went up really quickly because that was flammable. Okay, so really understanding the properties of the system that you're operating and how you can make sure that we can keep people safe and minimize the consequences, I think is one of the lessons that we can learn from all three of these events. So what do we do now? We still need to learn from the past. We need to try and pick up nuggets from these previous incidents so that we can start to make a positive change in the industry. You must identify your hazards. If you do not identify your hazards, you cannot take any further steps. And you need to understand them. So what are the consequences, and really understand the unmitigated consequences? And then what are the barriers to prevent or mitigate the events? And make sure that those mitigative ones are actually fit for purpose, because quite often what happens is we put the mitigative ones in, but they never work when we want them to work because we don't test them in an environment which will allow us to assess whether they would work properly. And then we need to manage your hazards through the lifetime and keep them alive so that everybody knows what it is, how we're protecting it, preventing it, and how we're mitigating it. And then finally, be vigilant and diligent and do this for the lifetime of your facility. And it is not an easy task to do this. So that's all we've got on the presentation. I've had one question in. If you have any other questions, please pop them in the chat. You can ask questions about these incidents, or you can ask questions about any other thing on process safety that you have any questions on. So I've had a question from Javid Khan. If a company is focusing on annual near-miss reporting, they give each department to submit less than 15 near-miss, but there's no focus or reporting on unsafe acts and unsafe conditions. So is it acceptable to focus on near-miss and not touch the reporting on unsafe acts or conditions? So what I would say, Javid, is it really depends on your barriers. If all the times when your barrier, whatever the barrier is, wouldn't work, is called a near miss, then yes, it's fine to focus on those. But if some of those unsafe acts are actually giving you an indication that there's something wrong with one of your barriers, i.e. your barrier health has been eroded in some manner, then I would say, no, it's not okay to ignore them. All of this information is leading information. You haven't had a release yet. This is giving you information about how your barriers are performing, and it's giving you a chance to fix it before all the holes line up and you have a major incident. So why wouldn't you take that? Also, if you do put a limit on, as you've done here, to say that each group can't report more than 15, what if there was 16? Are you going to penalize the group because they've identified 16 near misses? That also drives some bad behavior within your organization, and it can mean that you get unintended consequences. That is, people are trying to cover up potential lessons, right? Near misses, unsafe acts, you're trying to cover that up so that they don't count towards their metrics. Okay, so just be careful when giving targets. Yes, it's good to have a target, but make sure that you don't penalize the team if they find more, because they may be more proactive in this area. I've got another question from an anonymous attendee. Would you say these incidents were due to company culture? So in the Bhopal one, there is evidence that the facility that they installed in India was less inherently safe than the facilities that they installed in the US. And why is that? Because there was a perception that risk was more acceptable, or loss of life was more acceptable in India than it was in the US. And so that may have driven some of the behaviors, the willingness to override maintenance, to take things out of service, that may have driven some of that behavior. Also, that mindset may have reduced the training that people received. But I can't definitely say, because we don't know that information. In algae polymer, there was definitely something associated with culture. And in one of the reports that I saw, there was a suggestion that over time, the competence of chemical engineers and process safety had been eroded over time in this facility, which meant that when we did changes like the engineering change there, it meant that we didn't have the right people in the organization to make those decisions. Also, if you don't have the right competence in your management team to make decisions, then sometimes these high-level decisions get made at management and they don't have the information or the competence to be able to understand the impact on process safety. Because yes, process safety is very expensive, but still we keep making these mistakes. And it's not because we want to lose money or we want to kill people. It's because we actually don't understand the consequences of our decisions. So it's really important that you've got competence all the way through the organization, and that drives the positive behavior in your company. I have another question here. The engineering discipline provided good solutions to prevent process safety incidents, but we still have many process safety incidents. Is this due to operational failure, or do we need to increase batteries during engineering phase? So I'm going to answer this in two ways. So often it's very easy to just say, well, the operator didn't do what we thought they were going to do. But most of the time, when you look at why the operator did what we didn't want them to do, it's because we didn't give them the tools, the training, or the knowledge to be able to do the thing that we wanted them to do. And so they did the thing which they thought we wanted them to do, which is not the thing we wanted them to do. Or they did the thing which was aligned with what they understood the company drivers to be. For example, they understand the company driver to be not to take a shutdown, i.e. not to lose production. And so therefore their actions are aligned with the company driver. So yes, we can blame the operator, but we need to really ask ourselves, why did they make that mistake? The other thing, yes, we can improve things in the engineering phase. But what I would say is, as we learned at the Hazards Conference, nothing is new. And in all my HAZOP and LOPA, when we find major gaps, why is that? Because we didn't use the industry standard. We just designed it the same way we designed it before. And we didn't go back to the standard and ask ourselves, is this the right way according to the standard? So we have all those lessons. We have all of that information. But actually, it's such a large body of information. How is anybody ever supposed to know what it is they're supposed to do? But as a diligent engineer, we should, within our discipline, make ourselves familiar with the engineering standards applicable to the scope of work that we are working on, and not assume that the way that we did it last time was the right way, or the way that somebody else did it last time was the right way and in accordance with the standard. We really need to take that step and be proactive as engineers. The other thing is that we also, we spend a lot of time assessing the competence of operators and maintainers so that we can maintain our process safety barriers. We do not spend the same amount of time on assessing the engineering competence. I'm building something like a fired heater, and it needs to be in accordance with the NFPA standard. I put a load of engineers together. Have I checked that any of those engineers have adequate training or understanding of the NFPA standard? No. I've just checked how many years they've worked. I've had an interview with them. They seem okay. They'll fit in the team. Let's go with it. I haven't checked that they understand that standard. Now, just because they don't understand the standard doesn't mean you're not going to hire them. But what it does mean is you might have to proactively do some training for the team so that you can build up that competence within the team. And those are the things that we don't do. Also, when we do changes, the other thing that we don't do in the engineering phase is remind our engineers that when they support a change, they are saying that the change has been designed and engineered in accordance with the engineering standards of that date, right? Not of the date when the plant was originally built, of that date. And so the change is in accordance with that. And often engineers forget that. That is what they're signing as well. And so they should list the standards which they've reviewed the change against. So I hope that helps answer that question. If you have a further follow-on question, let me know. I've got another question here. Is a GenSuit a good tool for incident reporting and creating learning from mistakes in history reports? I'm not sure. I'm not familiar with GenSuit. So if anybody on the call is, if you raise your hand or give us an answer in the chat, I'll read it out so that we have an answer for that. What I would say, Gladys, when you are reporting, creating your lessons from mistakes or history reports, is have a look not only within your organization, but outside your organization, because you shouldn't be waiting for the incident to happen inside your organization to be able to learn. The other thing is a tool that I do know works really well. It's called the Process Safety Integrity site, managed by David Hatch. And it has a whole database of previous incidents. And you can search by the different properties, by the different severity, and that is, or by the different barriers that failed. And that is a really good tool for learning from others, i.e. outside your organization. So if anybody has any information on that, pop it in the chat. How can we improve process safety leadership during operation to prevent a process safety incident? So process safety leadership during operation is really important. It's one of the foundations for good process safety management, right? We need to have the leadership team engaged. How do we improve that? Well, we need to have somebody within the leadership who actually understands the process which you're operating and understands the hazards associated with that process and the critical barriers associated with that. Because otherwise, the leadership team are driving blind, right? They don't understand the consequences of their decisions. If you don't have somebody in the leadership team who has that competence, you can manage that by having somebody from lower down in the organization attend some critical management teams, or you can also do some proactive training like the fundamentals of process safety with the ICME or other similar courses. You can also use, so on the website, I've got some checklists which allow managers to go and have proactive structured questions or structured conversations with the front line. And by the front line, I don't just mean operators or maintainers. I mean operators, maintainers, engineers, whoever is doing the actual work. So there's a structured list of questions that management can pick up, and they can go and have a structured conversation. In doing that, they achieve two things. One is that they improve their competence on that topic without being an expert before they start the questions, right? Because they've got a structured list of how to have that discussion, and the other person is helping them to understand. And the second thing is that they're improving their competence in process safety all the time. They are communicating to people that this is an important topic for me, even though I might not understand everything. This is important for me. This is important for the performance of the business. And I am learning as well about what's happening at my site, which is often more important than learning about process safety in general, to learn how it actually happens at your site. I hope that answers that question. I've got another question. What is your best practical advice for making the management team hear the safety team? This is a really difficult question, right? What I would say is that you need to have a good relationship with the leadership team. Okay, they need to understand the importance of what you're doing, but also you need to make sure that you're not bothering them too much. And the final piece of advice is that you always go with a solution. So whenever I found a problem in the organization, I would say, okay, yeah, I need to go and talk to management, but what could we reasonably do about this? And I would come up with a few ideas. That is not saying that always those ideas were the ones which were chosen, because sometimes when the management team saw it, they chose something different, which I didn't think that they would support, or I didn't even think of before I went. But it made it not feel like this is the end of the world and we can't do anything about it. It moved them into solution mode. And so therefore, when I went to them with any problem, and that wasn't very often, they were more receptive to listening to me, because they knew that I would have some way of fixing this problem. It may not be palatable, but it would be some way of fixing the problem and making us safe. Okay, so that's what I would advise for the engagement. Also, something that I found really useful, just to start the conversation with the management team, was to do something like a book club with the management team, where we met 3 times a year. So in the first meeting, what I did with the management team was explain what process safety was at our site. So what were the major hazards, how were we controlling them, and how were their previous or historic decisions impacting process safety on our site. Okay, then I gave them a book to read, and we read it in 2 parts. In the first session, we reflected on the first half of the book. It was really a structured conversation about something, that again, looking at how this applied to our site. And then in the last one, again, it was a structured conversation about the second half, again, looking at a different part of the process safety management system, which I wanted to improve with the management team, and looking how we could improve. So I hope that helps, but the main thing is just to keep an open dialogue with them and form that relationship, which doesn't happen without proactive proactive measures on your part, right? You need to make time for them, and you need to make sure that they understand the importance of the discussions with you. Okay, so the next one is reducing costs during construction can be a factor to not having the right barriers, which increases the potential of process safety incident frequency, which is the best option to reduce cost and put effective barriers in. The best way to reduce cost is to use inherently safer design approach early in the design, and then to keep those decisions live throughout the project phase. So what often happens is we put inherent safety in at the early parts, and then we go through a cost-cutting discussion, and we say, oh no, we don't need to fully rate that vessel, so we'll put relief valves in, or we don't need to do this. But we don't always evaluate the life cycle cost associated with that, or the commissioning cost, or the time associated with commissioning and testing, because this is now a different thing that we have to commission and test. Okay, or the maintenance cost of the lifetime, or the replacement cost associated with all the parts. So what I would say is you keep key decisions sheets which are associated with inherent safety that you have applied early on in your design, and you keep those alive throughout the design. If you're making any change which could impact that decision, you use a interdisciplinary team to assess that. You don't do that in a one-off without approval. And perhaps you elevate those decisions to a higher level within the organization. Commissioning is a really tricky time, because often queries come through engineering queries and they go to single discipline. And so you can often miss things within that commissioning phase, which can impact the process safety performance of your facility for the entire life of your facility. And sometimes you can't go back, right? Maybe it's the height of a foundation, maybe it's a material selection, maybe it's the integrity of one of the tests, or the effectiveness of one of the tests. Sometimes you can't go back, right? Once you've built it, you can't go back because it's been built in that way. So it's really important to have a sense check of those engineering queries to see whether they are really single discipline. And if you tie them back to those key decision sheets, or if you have a bow tie with all of the key barriers listed on there, and if the decision is associated with one of those barriers, you do not allow it to be a single discipline decision, even if it may seem to be. So those are the pieces of advice that I would give you, but it is a really tricky stage of the facility's life, because things are changing so fluidly and you're trying to get something done to a tight deadline. The last piece of advice I'll give you is that 61511 gives you a very clear requirement for instrumented functions to develop something called the safety requirement specification. If you extend that and develop a safety requirement specification in the design phase for all independent protection layers that you credit in the LOPA, and then you mature that to be a commissioning procedure or an operations performance standard, then when you get into the commissioning phase, you will very easily be able to see the things which you could compromise on or not, because you know what you are trying to get that barrier to do over time. Okay, I hope that answers your question. If you have any more, just let me know. I've got another question from Javid. For the info, your previous webinars or trainings are available on YouTube. Yep, all of the previous webinars are available on YouTube on my channel. And we've also got a TikTok channel, which has got some quick tips that you can use to go and have a safety conversation with people in the field, and then have, you know, improve your process safety management in that way, and also improve your knowledge about different things, which maybe other people in the organization know, but you don't. Okay, so that's what the TikTok channel is for, but all the other webinars are available on YouTube. So those are all the questions I have. Are there any other questions? I'll give it a couple of minutes. And if there aren't any other questions, what we'll do is we'll move to wrap up. So I'll just give it a couple of minutes. What I'll do is I'll talk about what's coming next, and then if we have any questions, I will answer those. If not, we'll wrap it up then. So what's coming up in the next month or the next year? So process safety with Louise. So the next session will be the first week of January. We haven't set the date and time, but if you've attended this webinar, or if you follow me on LinkedIn, you'll be able to see the posts there about when that is. And then I've mentioned already that we've got TikTok, which is Practical Process Safety. If you want to follow us there, you'll be able to get some tips on what to ask on your operation rounds. There are some useful resources on my website for training, templates, auditing, etc. So have a look there and see what it is you can use there. If there's something that you need help with and the information is not there, just email me or send me a message on LinkedIn, and I will try to get the information available there to help you with whatever it is you're doing. I've also got some courses coming up in January. So I've got a hazard course, HAZOP course, LOPA course, a process safety metrics that's leading and lagging metrics, and explanation about the difference of those, and then risk assessment methodologies. These courses are not courses to make you an expert in hazard, HAZOP, or LOPA, etc. They are courses which give you practical example of applying these methodologies. And they're also very short courses, so 2 to 3 hours, which means that you can fit them in around your other commitments. So if you want to join us for any of those, they're very similar. If you attended any of the masterclasses, they're very similar to those, but just a little bit extended to improve or embed the learning. Okay, and obviously you can attend them as many times as you like, because each time we run them, they will be different depending on the people who are there and the questions that are asked. Okay, so that's what I've got coming up. I'm going to stop sharing again. I've got one more question on the Q&A, and if we don't get any more after I've answered that, then we'll wrap it up. So I've got a question about what good references could we use to know more about process safety. The CSB channel, the CSB website, and the CSB YouTube channel are really, really good resources to learn about process safety management. On my website, I've got a lot of articles as well with practical advice on process safety management, so you can have a look at those as well. If you're looking to make a bit of a bigger investment, there's the Fundamentals of Process Safety course by the ICME, and that is also a very good course which can give you a sort of overview of all of process safety management. If you're looking to get a qualification, you can also look at the CCPS. There's a risk-based process safety course, which then follows into a qualification. If you're looking to understand a little bit more about instrumented functions and the life cycle, i.e. from design all the way through to decommissioning, you can look at something associated with certified functional safety practitioner or certified functional safety expert with providers like Method, ResTech, or Exceeder. Okay, and then if you follow me on LinkedIn as well, I give you a lot of good reference material there. If you want to learn from past incidents, there's the HSC website, the PETAL website, WorkSafe BC, the CSB, and there are other regulators, but I'm not aware of their websites. So I hope that answers your question, gives you, there's a lot of information out there. The problem most of the time is knowing where to look, which is where that Process Safety Incidents website by David Hatch comes in really helpful. Okay, I've got another question. Do we have a specific document which contains all applied process safety requirements for oil and gas plant? So I don't know of a specific document which is specific for oil and gas plants, but there are a few different process safety management frameworks out there. One is the Energy Institute, and the Energy Institute, obviously, a large number of the people or the organizations which were involved in the development were coming from oil and gas facilities. And so that maybe can be seen as more applicable. There is also the CCPS structure, and that's kind of a US based, but it's also risk based. So you can use that. But and then there are other process safety management frameworks, but those are the two main ones which I use. There's also the OSHA framework, but that is more structured towards the US rather than specifically for oil and gas. But basically, process safety management is universal regardless of what facility you're operating. You just structure the intensity of your process safety management system based on the hazards that you have at your site. If you have the potential to kill the entire neighboring town, you're going to put a lot more effort into your process safety management system rather than if you only have the potential for minor injury on your facility. So make sure that whatever you do for your process safety management system is proportional. Okay, and that's based on people, environment, and also asset or financial risk. What appetite do you have as a business to take on these types of incidents? So I hope that answered your question there. I have another question. What are the main differences between process safety and process safety management, or PSM? So process safety is sometimes what we refer to as the person or the role, and the process safety management system actually covers a much broader range of topics. It includes permit to work, which is not typically seen as a responsibility of the process safety engineer. It also includes things like document control, again, not typically included as a responsibility of the process safety engineer. So it has inspection and maintenance, it also has leadership. So a lot of things which are not the responsibility of the process safety engineer. The process safety manager may be responsible for all 20 elements. And so their role may be a lot broader than the role of a process safety engineer. Or you might decide to divide the responsibility for process safety management through different leaders in your organization. So for example, you might have the integrity leader who manages maintenance, operations like handover, etc., and inspection. And then you might have the HSE, the health and safety, who manage things like permit to work and those types of things. And then you might have sort of a facilities manager or an IT manager who manages things like document control. And then you might have the process safety manager or something similar, who manages other things like hazard risk assessment, identification, consequence management, etc. Then there might be some in emergency response is typically in the HSE field. And again, depending on where your safety engineer sits, maybe safety engineering comes under one of your other disciplines. So it depends on your organization how you split it, but a process safety engineer's role does not generally cover the entire range of requirements for process safety management. So you just have to be really careful when you assign the responsibility or the accountability for process safety management, that it's at a sufficiently high point in your organization that it covers all of the 20 different things that you need to manage. Because if you don't put it sufficiently high, then the person who is accountable for it will not be able to drive good performance in the other areas because they will not have sufficient seniority. Now, being responsible is different. And as I said, you can split that, but the accountability needs to be sufficiently high in the organization. Okay, so that's all the questions we've had. Thank you. Is there anything else anybody wants to add or ask before we wrap up for today? I'll just give you a moment. If you do have any follow-on questions, you can always message me on LinkedIn. If I think it's more appropriate to answer in the next panel, I'll save the question for next time. But if I can answer it on LinkedIn, I generally will. Okay. Well, if there's no other questions, then thank you all very much for your time. I've really enjoyed the session. It's really good to attend these and hold these. And if you need anything else or you want to discuss for the next topics, just let me know. That there's a little survey at the end of this. Let me know what you think or what you want to hear about. Okay. Keep safe, guys. And if you are celebrating Christmas, have a good festive period. Okay. Thank you.